All right, so today's topic is how Thermo Fisher streams data insights on the Databricks Lakehouse platform. My name is Surya. I'm a Senior Solutions Architect with Databricks. With me, I'm joined by Ashish and Feng, who are Senior Directors at Thermo Fisher Scientific. Today, I'm going to present the how part of getting into the insights on the Databricks Lakehouse platform. So we're going to start there. Awesome. So simplifying data analytics and AI. This has been always a challenge, right? It's not simple. Coming to the room, all the way walking 10,000 plus steps, it's not easy. At Databricks, what we were able to do is really look how we can simplify this data analytics journey for you all. That's why we have coined the term data lakehouse. What is a data lakehouse? Data lakehouse typically consists, on your left-hand side, is a cloud data lake combined with governance, a data reliability platform, with performance, a Unity catalog for fine-grained access control, and to be able to cater different personas in the organization. This is your lakehouse platform architecture. So I'm going to spend 2 minutes to explain how this fits all together. Right? Cool. So let's look at the cloud data lake right at the bottom. The cloud data lake is very, very important to all of your data analytics journey. The reason it is important is it is that data lake where you are storing your structured, unstructured, and semi-structured data. I am sure none of you in the room is directly taking the data from source system and consuming it for your analytics and insights, right? You're still staging it in a data lake. On top of that is the brains. It's called the Delta Lake. Now, I'm going to spend 30 seconds to explain what is Delta. Delta is an open source format of storing structured, unstructured, and semi-structured data. It is the format where you're able to use native programming languages to consume that data, right? Now, if you look at the backend system, so just to double-click on the Delta Lake, Delta is a transactional system on a Parquet file format. Parquet file is also an open source format. But what we, as Databricks, are able to do is optimize that Parquet format by bringing in transactional system on top of the Parquet file format. That is what is Delta. Now let's take a step back. Without Delta, how the world looks. Without the Delta format, if you are using Parquet as your format to store data, what you are doing is whenever there is a change in your structured or unstructured data, you're basically reading all of that data into the memory, find the changes row by row, column by column, and then make those changes, right? Delta simplifies all of that for you. It has features like change data feed, which allows you to do change data capture out of the box. It has features for you to do time travel. So what it allows you to do is, if you want to go back a version of your data set, you can just query your data set, which is underlining in the Delta format by a simple programming language like SQL. So all of the excessive code that you are writing to store versions of the data, to be able to do a backout strategy when you implement a lakehouse platform, is gone. Well, do not look at it as just excessive code. For an organization at enterprise scale like Thermo Fisher, they have to do regression for every release. Think of the overhead on the data engineering teams. Think about the abilities of data scientists to not able to test on the data sets. Now, talking about data scientists. Data scientists typically access these data sets, which are typically raw in format. And why is it important? It is important for data scientists to access the data so that whenever they are doing model building, it's not biased, right? As simple as that. And when they're doing so, they also create an ML ops platform or pipeline together. Once they do that, it is important because let's say there's a schema drift. Let's say there is a data drift. Let's my model is not performing as efficiently as it should be. What they need is access to the copy of the data in production. And here comes the whole back and forth communicating with the data stewardships to get access to that data, to be able to test their model on why it is not able to perform at how when I built it and deployed it in production. With Delta as the format, you can create Delta clones without touching your production pipelines that are loading that data. It is a super powerful feature to make your teams efficient, to make your pipelines to be tested not only for data scientists, but for data engineers, right? So that's the power of Delta, all right? Moving on, I slightly touched base upon data stewardships on getting access to those data sets. What is important is also data governance piece naturally, right? That's where we have Unity Catalog as a feature that is sitting on top of your Delta Lake to manage data governance and data set policies, right? So the power of Unity Catalog is not only on governance, but it is a fine-grained governance on your data that is sitting on your S3 bucket. Now, what does that mean? Unity Catalog allows you to define attribute-based access controls. So at a column level, at a row level, now you will exactly know John Smith tried to access that data set or needs access to that data set. Well, that's not it. John Smith, once getting access to that data set, will be exactly able to figure out what is the predecessor process and what is the successor process, also called as lineage. This is important for a Lakehouse platform at an enterprise level because it does it for you. You do not have to put things together to get lineage information out of it, to get the governance policies that are on a data set. All right? Cool. Now, putting it together, we talked about the data lake. We talked about the Delta format on the data lake. We talked about Unity Catalog. That empowers an entire organization with different personas like data engineers, data scientists, data analysts for achieving their business use cases. All right, cool. So moving on to the next one, this is how several organizations around the world are benefiting from the Lakehouse implementation. So guys, you're not the first one to try it. This has been a proven and tested framework on top of Databricks to implement that. What is interesting in all of this slideware is the Lakehouse platform, along with the power of Delta, has been given a leader status on the DBMS. So this is Database Management System. Now, what this enables each of your organization is not to implement several copies of data just to get performance, to get governance on the data. Well, that's one part of it. The most important part of it is this data can be structured, unstructured, and semi-structured. So all the things that we talk about getting users closer to your data is now possible. And Databricks Lakehouse platform allows you to implement it. Today, we're going to see one example from our customer, Thermo Fisher, how they have implemented this. So we are going to talk a lot about how. We're talking about when and what has been implemented on it. All right. Now let's look at where other industries are in typical data and AI maturity curve. Is there anybody who wants to be on the left-hand side of the interval of this maturity curve? All right, perfect. So you're all with me. All right, so we always wanted to get to what will happen stage on this data and AI maturity. We've heard this morning on the keynote as well, that everyone wants to be on the state which is what will happen. And that is possible when you are able to bring your data scientist teams to build models on the raw data set. And it is possible with Lakehouse platform when you have Unity Catalog as a governance tool and Delta as the format to store your data. But let's talk about the reality. There are still enterprises who struggle with data analytics and AI, right? We all know this, right? And we have also seen that realizing this requires bringing in two systems together. But let's go back 10 years. When we only had one system to manage, which is the data warehouses, we were suddenly introduced to a term of data lakes. And we all jumped upon that, right? We built data lakes in our organizations to enable data and AI capabilities on the data set. Well, that was one reason. But then, once this was happening, suddenly enterprises started building data flow processes between these two disparate systems. Now, what happens is the data suddenly flows in both directions, right? A data scientist wants to access a product dimension table because that is a fully qualified data set for a data scientist to join with the raw data set, right? That's what you need, right? Dimensions, perfect quality, so one more less EDA task, exploratory data analysis task for a data scientist. So he loves to go to that system just to get that access to that data. But hey, with the lookup data, which is a dimension table, he still needs to join with the raw data set that is arriving now on your data lake. And then suddenly a requirement comes where data scientist has to enable their machine learning algorithm on streaming data. Well, I don't want to predict the future to yesterday. I want to predict the future now as it is happening, right? So let's look on how Databricks brings together today the capability of the Lakehouse platform. So I'm going to peel the onion a little bit. Let's take a deeper look on how the platform transforms into, right? First and foremost, the Unity Catalog, right? Now, more and more organizations are getting to the right side of the data and AI maturity curve. The natural evolution to the process is, hey, let's talk data fabric. Let's talk data mesh, right? Data mesh, data fabric is not a product. Nobody can offer it, right? It's a process that enterprise goes over after decades of building these tech stacks and tech debts, right? So that's a natural evolution to that, right? And Databricks, along with Unity Catalog, allows delta sharing on top of your data sets. Now, why is it important? How is it different? It is different and important because of the capability of data in the delta format that you stored. It suddenly gives you an ability to share that data set with anybody who may or may not have Databricks as a system to process that data. So this delta format is truly an open source format, right? You can share the data, who can consume it, join it with Pandas as a data frame, bring their Power BI analytics tools to bridge the gap between BI to AI, right? Now, talking about AI, Databricks has an ability to do AutoML on your data sets. Now, AutoML is a pretty popular term in the industry, especially in the data science community. But what Databricks has done is given AutoML an open source outlook to this whole idea. what Databricks allows you to do is a glass box approach to AutoML. What that means, it gives you full control on every iteration of that hyperparameter value that is being tuned while your model is run on the data set. That means when John has to start writing or bring his own library to develop that data model or integrate into that data set, he doesn't have to start from scratch. There will be a pre-built notebook available for John to join with the data set in their Delta Lake and bring in data and AI. Now, AutoML on Databricks also gives the capability to data scientists to measure their models that they have built against a machine. How do you know that a model that somebody is saying is the best because it is 83% efficient or 95% efficient is truly the best? Is by comparing it what machine does. AutoML gives that capability to all the data scientists to verify they are on the right track. And the best part is they don't have to sit in the system to let that whole operation happen. They can just click the button. The AutoML will tell them what is the best model and what are those hyperparameter values that it thinks is better. Right? So that's the open source approach on the Databricks for models. Now comes the favorite part, ETL. We heard this morning on the keynote, right? How do you do extract, transform, load? Databricks has DLT, called as Delta Life Tables, a declarative approach to do your ETL on the Delta Lake. Now, what is a Delta Life Table? A Delta Life Table basically empowers all the data engineers to not think about the infrastructure, not think about the instance types, not think about the scalability aspect of it, but just focus on accommodating that business logic. Well, DLT takes it to the whole new level. Until today, without Delta Life Tables, if you're building an ETL pipeline, what a typical data engineer does is once data is stored in your data lake or Delta Lake, they read it back again to make sure it adheres to data quality matrices that you have defined. And then they have a whole reject framework or an error framework to capture those. With Delta Life Tables, you do it before the rubber hits the road. So no more bad data into the system in the first place. And when I say into the system, remember, once the data is loaded into the table, it is immediately available from your business consumers to consume off of that. Right? So Delta Life Tables powers that. Well, no platform is complete without SQL. Therefore, we have Databricks SQL to query data, which is unstructured or semi-structured on your Delta Lake. Right? Now, let's talk about performance. This is very, very important when you are in a cloud data platform. Because if your job takes more time to run, you are just spinning up cycles of the VM cost. But hey, you cannot have 200 users checking their code line by line if it is written in an optimized fashion. So therefore, what Databricks out of the box gives you is the right price performance for every line of code you write on the platform out of the box. That means if you take your code that is there in your existing system and just run it on the Databricks platform, you should ideally see huge performance gains. No more fine-tuning of the code, right? Now, why Databricks is able to solve this problem is, as the creators of the Apache Spark, we know Spark works on a lazy evaluation fashion. And therefore, we exactly know what is going to be executed by the VM that you will provision. And hence, we were able to optimize what is going to be run what will happen the right side of the data NVIDIA maturity curve. All right? So that's what we call it as photon. So the Spark that you're running on Databricks is not your typical performance optimized Spark, which is 2 times or 3 times faster. It is the Spark that will be 30 to 36 times faster. Well, let's say I got this number wrong. Will be 7 to 8 times faster? Still a huge, huge advantage. Let's look at some numbers. Here is a typical TCO savings when you're running your Spark on a regular open source versus the Photon optimized Spark on Databricks. This is why you need to be on the Databricks platform. Not because of the overall 26% TCO savings. Think about this 26% into 200 developers in the enterprise. That cannot be measured. That time cannot be given back. All right. Let's talk a little bit more about Delta Life tables. Like I said, it accelerates your ETL development. It automatically manages your infrastructure that you need to run these pipelines. Now, what does that mean? It means that if a data scientist has to run an algorithm on a smaller data set and then suddenly run it to a larger data set, they are just leveraging the pipelines and just saying, a flip of a switch saying, hey, now run it in a production mode versus a development mode. But with Delta Life tables, we take it to the next level. What we get the capability is check in and check out code with Git. So now you can literally branch out or fork the existing main from the Git, run the process with the power of Delta clones on a production copy of data set, test it, and then just flip a switch to deploy it. It's a CI/CD at a whole new different level. Today, Thermo Fisher has used this and accelerated their journey, and we're going to see how they have done it. All right, so let's see what does a typical unified data platform means on Databricks. As a typical process, like let's take an anatomy of a data product, right? Reading this slide from left to right, you will have data sets being landed into an S3 bucket, right? So you need data ingestion process to land those data. Now, this data can be streaming, this data can be batch, this data can be pulled from your source systems rather than pushed, which is only changed, which is the CDC data. Now, with Databricks, you have capabilities like Autoloader. Autoloader, which is the Cloud Files API, gives you the power to track down the data sets that has already been processed, to find out the data set that has been changed from your source system. You do not have to sleep for 10 seconds to go back to your source and fetch the new data set or maintain a set of files that have already been processed. It does it for you. All you do is call the API. Now, once the data is landed on an S3 bucket, what you do is store it in Delta format. Now, how does we empower that? We kind of also talk about the medallion approach to the anatomy of a data product. And it splits between bronze, silver, and gold. So your data, which is raw, in the raw format, is stored in the bronze layer. Some people call it ingestion layer. Some people call it staging, right? Then you filter it, augment it, make it ready for a dimensional model to be uploaded with its facts and dimensions, right? So before that, you store it in the silver layer. This is exactly where your data scientists will be accessing the product dimension instead of going to a third-party system, all in the same S3 bucket. Finally, it basically goes into the gold layer for BI tools to access this fully aggregated data, right? Notice the Delta Life tables and the spot structured streaming that is empowering this medallion approach to the data sets. Finally, the data science and machine learning. Now, it is one thing to build or code or accommodate for a data of a business logic that you're trying to do, but then it's another thing to maintain it. You typically hand it over to an application support team or a maintenance team to maintain that code, and you move on to the next project. Databricks gives you that interface to monitor those workflows historically. It tells you how each task is performing historically in that same interface, right? So it basically simplifies the whole stack for management of or building workflows and doing orchestration of these notebooks. Now, again, what a platform without Databricks SQL? So you have the SQL capability to connect to these data sets. Now, I talked about Unity Catalog at length, but you see how fundamentally it is part of the Databricks platform, right? So it is automatically available as long as you're reading and writing your data from the Delta Lake sitting on the S3 bucket with your notebooks and Python code on the Databricks platform. It automatically does for you. And hence, you build a lakehouse. This gets complete when you bring in BI tools to connect onto that data set. And therefore, what Databricks enables is this whole modern data stack. It thrives into your modern data ecosystem, right? Now, I talked about anatomy of a data product, talked about enabling data fabric and data mesh. How this Lakehouse platform on Databricks allows you to build a data mesh is like so, right? Without changing or re-architecting what you have built so far, now you have an ability to build the data mesh on the data Lakehouse platform. And like you have listening to me for like 20 minutes, this has become eventually an evolution to the process, right? This is not something that you architect sitting around it, right? Naturally, if you are using the Lakehouse platform and then medallion architecture, you automatically get into implementing the data mesh on the Databricks Lakehouse platform. That said, we have been successfully implementing a smarter healthcare ecosystem around the globe. Databricks is now fully focused on building this ecosystem around health and life sciences. So let's hear out from Ashish, Senior Director, Data Platform Analytics at Thermo Fisher, on the stage to see how they have implemented this.
Thank you, Surya. It was, I'm sure, a lot of information. And I would just call it AWS reInvent is more or less like an information overload, right? It's just you get through the 3 days, and then we figured out, OK, where do I go and play, as there are just so many opportunities out there. So with just kind of checking onto the pulse of the team here, let's just have a quick check of how many of you have heard of Thermo Fisher or know Thermo Fisher at least. OK, so OK, good. So around 40% of the people. OK, that's good. Now, a quick fact check, right? OK, how many of you have had a COVID test in the last 2 years? I'm sure almost 100% of the room, or if not more than that. So Thermo Fisher is one of the key distributors of the PCR test. We have distributed over 140 billion tests into the 140 plus countries. And that's just one of the key facts on the overall spectrum of life sciences business where Thermo Fisher operates. So it's just a kind of a quick fact check of where Thermo Fisher is. And then in terms of the numbers, it's a $40 billion revenue company with 100,000 plus colleagues. And then we have one of the largest R&D funding in the industry, specifically on the scientific industry, with $1.4 billion of scientific investments on the R&D business itself. Today, I think where we kind of drive is more around the motto of Thermo Fisher is never leave any customer behind when it comes to science. We are scientists by core of our business. And then we take extremely, extremely pride on our mission to enable our customers to make the world healthier, cleaner, and safer. And that mission just kind of encompasses a lot of the capabilities, how we serve the humanity and how we serve the science to make this world better. And COVID was a great example for us as a company, that how we were able to come together and serve a lot of the need of the hour for our business in the ecosystems. So that's just a quick view of Thermo Fisher. Today, as I said, we are scientists by nature, and then we operate into many verticals in the life sciences, healthcare, applied segments, and pharma and biotech. And we have a vast variety of end-to-end workflow, like you call it, from a bench to the lab or to the patient in some ways, where in every spectrum of the business, we operate within the industry out there. Now, given the history of Thermo Fisher, where does Databricks and where does data play into our environment, right? So Thermo Fisher has been a long, I would say 50 plus years or even more than that, years of an old company. And we obviously had a passion to see how do we drive data as the core of the company's value and as an enabler for the organization. Within any other large organization, you have transactional data which you capture from your ERP, your CRM systems. You have a customer interactions data from your website, social channels, instrument data, supply chain data, internal fragmented ecosystems, multiple warehouses in a large company. The goal on us was, how do we bring all this together, right? There is a lot of fragmentation into large companies. How do we bring them together and find a single platform where we try to source data once, but consume it more than once? Because the last thing we want to do is hire another 10 engineers to move data from one platform to another platform and just keep moving the data around into the value chain where you can get more use cases of this data. And that's where Databricks came into a big application of those use cases on our platform, and I'll just walk through some of those use cases in a minute. But in a nutshell of any data platform, right? You go to any other company, any other platform, you need to acquire the data, you have to model the data, and you have to consume the data. So on our foundational principle, what we developed was we created very strong frameworks from the start of the programs and the projects. As when you work on a Databricks platform, it's an engineering-heavy processes. And when you are creating an engineering-heavy processes, your key goal is that how do you make them scalable and how do you make them repeatable? So creating those engineering frameworks on the platform was the core principles, that if I'm trying to doing a data ingestion, I don't want to keep writing those ETL over and over. We need to create one configurable platform or one configurable pipeline, which is easy to ingest data as fast as possible. So that kind of allows us to enable, to accumulate and unlock a lot of our enterprise systems to bring their data onto our raw zone or a data acquisition zone from our environment's perspective. And then the second path is, when you are in a fragmented business, how do you bring the allyship and partnership with our business teams to get them to all work on a common platform? Because that's easier said than done in many of the organization, where the value is that how do we bring the supply chain function together into a one common framework? How do we bring a finance? How do we bring the services organization? All of them into that common framework. And once you unlock that value of that common framework for one division, you can scale it to across the enterprise in an essential. And then we were able to bring a lot of those environments onto our standard platform. And then, as I said, on our reusable, scalable platforms, it's not only data ingestion. Now, how do you apply the data quality checks? How do you apply the data observability? What is the DevOps processes? How do you monitor all those processes? Cloud cost management. All those standard frameworks on the platform allowed us to make sure that what we are building is something scalable, supportable, at the same time, cost managed, as the last thing we need is that we keep pumping the data and we don't know how much of the consumption we are trying to go through on these data sets. So again, a lot of those capabilities is what needed from our ecosystem perspective. But one of the key principles onto all of this platform is we don't want this to be seen as a IT-only platform, right? The moment you say that this is an IT platform, you lose half of your business. This is a company's platform, and where you need a strong partnership and an open architecture platform where you can try to leverage the Databricks resources, AWS resources, train the people in the business, and work as a community to bring this to life on an overall environment. So Few use cases what we drive through on this platform. Like Surya said, there are data warehouses use case. So this is a typical data warehouse use case on a traditional world. You try to find an Oracle database, pipe in the ETLs, convert and create a reporting on top of those platforms. We achieved all of those through Delta Lake. And Delta Lake on a Parquet format with a financial data, with a full ACID compliant data sets, we were able to create a very standard reporting around the financial data for our business teams. And the value of Databricks having out there, having the storage and the compute layer being available to us to scale, we were able to get through almost 6 to 8 times a day refreshes around these financial data sets. And now going through the close process, our teams were getting the faster access throughout the financial close, and we're able to drive through a lot of the productivity savings as well as faster access of the information on this financial data lake platform. The other value is it's not only reporting and analytics, right? Now, having the data in the centralized platform, having the data curated, validated, getting into a gold layer, we were able to unlock some other use cases for our machine learning and leveraging Databricks AI ML capabilities to drive more insights and just give this platform to our data scientists onto that ecosystems. Along with that, our finance team created some data applications where you can connect the data services through API engine onto the same data sets and serve the consumers through a UI layer on a data apps platform, essentially. So it's, again, a single-stop shop from a source it once, consume it more than once, essentially. The second use case, which we talk about near real-time streaming, and this was more or less like a practical use case when you have fragmented applications, fragmented systems, a customer care needs to find what is the status of an order, and how do I get the latest information about when a customer calls me, what's the status of my order. You can't go to 50 different ERPs or 10 different ERPs to go and find the status of the order. So again, leveraging Databricks real-time ingestion practices, we were able to integrate the data into the bronze layer, silver layer, gold layer, and push this data into an open source platform with a UI on top of it, which allows the customer care to quickly type in any order information and look through the latest order status, essentially. So again, the same platform, the same data. One use case was for the BI. This use case is more of a driving an application for the ecosystems onto the platform. And again, this enables us to do more near real-time analytics. So customer, when on a call, it's usually less than a 5 minute of a refresh time from a customer care agent perspective to get a latest status of an order. The other use case, again, like we talked about Thermo Fisher being a scientific company, we have a lot of instruments in the field. And especially when you have an instruments into the field, it's very, I would say, appealing to see how we can be a differentiator as a company to give more predictive analytics to our customers for the instruments into the field. And the use case here was we have an ultra-low temperature freezers where many of the biomedical companies or the big labs store the blood banks, basically. They will have a very critical human supplies sitting into those freezers. And at any point in time, how do we get a good amount of telemetry data from those instruments which can allow us to predict as well as notify the sites when something is malfunctioning onto those freezers, essentially. This was the use case where we were able to, again, go and connect component of our business instruments, get through the real-time data through the telemetric analytics or through the telemetry data available onto the edge computing, bring those data into the Kafka queues or into the Databricks platform, move them through the channel of the kind of a bronze layer, silver layer, gold layer, and able to create an algorithm to identify which telemetric sentiments or which telemetric touch points are giving us an information that a temperature is getting dropped in the freezer, as an example. And those temperature drops get notifications sent out through an SNS alert to the customers at the site, saying that something is malfunctioning onto your freezers, essentially. So that's a real practical example of how we were able to bring IoT data, again through the same platform, same engineering processes, but now giving the real-time use case at an end customer level to bring them a predictive notification about what's happening at an instrument at a site. Now, again, this was just one of the Q use cases. And now the goal is that the team is trying to use this telemetry data and trying to identify if we can predict a part failure. Because that's the holy grail, is that before customer knows the freezer is going to get out of support and I need to pick up a call for Thermo Fisher to call a support, if we can predict the part failure, we could be much more proactive to our businesses. So that's the kind of next evaluation where the team is trying to leverage, again, the same platform, the same data, to create more capability onto the environment. And then the last use case, or I would just call it as the first use case, to be honest, was what brought Databricks into our platform was around 4 years back when we were trying to just noodle around into how to apply data science for various platform use cases into the company. We found Databricks as a kind of one of the platform choice and say, okay, looks like we need to play around with this platform. At this AWS reInvent, might be 4 years back, sitting through the sessions, listening about the capability, is where we started giving this platform access to few data scientists into the company and say, have a play date, basically, right? Just this is the platform, go play around with it and see, are you able to use this to meet your needs? You have a existing Python notebook sitting into your desktops. Let us give you a platform, and are you able to run with those platforms out there? And with few success stories, now we were able to completely, I would say, commercialize this within our own company to give every data science a platform of choice. As we start bringing data onto the platform, now you have a playhouse to go and build your own data model from a full democratization perspective, because this is where IT does not come into the way. This is where IT enables the platform, gives the platform to our data scientist, and then our data scientists were able to create the ML models, able to store those data models, manage the end-to-end processes within their ecosystems as a fully governed and fully self-controlled ecosystems within the business. And then now with Unity Catalog, we are able to get through some of our core platform data access setup such a way so that we can create a persona-based data science access to a specific part of the business. Like as an example, commercial trying to do a segment analysis. How do we bring those data to the commercial team, only their specific use case data into the data science platform? And this has enabled us to, again, unlock the data science opportunity at a scale within the company with a lot more capability than trying to go and solve one business at a time within the organization. So with that, this journey was obviously not simple. We have been on a 4-year journey so far. So few of the lessons what we learned along the way was, the number one was experimentation, right? So we by nature, or if anyone by nature is an engineer, they would love to experiment, and you learn when you experiment, essentially. So a lot of our initial learning when we were trying to build the platform, understand the platform, was all around experimenting around the business use cases. But at the same time, those experiments were not just an IT experiments, but how do we take a business use case and experiment with this technology and see if we are able to solve a small use case out there. The second element was partnership. It's not possible just sitting in an IT door to do this work, but we had to get through our business, Databricks, AWS, all vendor on the door. How do we leverage the partnership and see we can drive the right, I would say, the intellectual from the overall company as well as the partners to drive the right outcomes for the organization. Talent upskills, right? I'm sure most of you are aware of it. Finding a data engineer is like I would just call it as finding a needle in a haystack nowadays. Like it's not like a data science anymore. So a lot of the effort was that how do we train our teams? How do we have them passionate about learning the new tool sets? How do we make them a little bit more interested in experimenting with this technology? So a lot of the focus has been around talent upskills and training rather than trying to find a talent from outside. As You obviously have to go find that, but it could be expensive many times. Agility, I'm sure this is just like the norm in the nature, but learning through our voice of customer, learning through our first product of how do we solve BI? Okay, now we are able to solve BI. Can we apply those learnings onto real-time streaming use case? How do we walk through those use cases based on the learnings of the other use cases? Was able to help us to drive a lot more capabilities out there. And then the last element is cloud cost, right? It's not cheap. Obviously, you have to, like Surya said, the good news here is that every piece of the code, you can measure the cost at a node level, at a DBU level, and this allowed us to very minutely create some dashboards and measure our cost, that as you have a large developer community consuming these data sets, how do we create some more proactive alerts to curb certain cost when things are going above certain thresholds, essentially. So that's just a few of the lessons learned. And then our journey still continues, right? We have been on this journey. Databricks is evolving as a platform. We are evolving as a company. We are evolving as a kind of consumer of this platform. And then where we see we need to go ahead is we need to figure out how do we continue to build more data governance and security frameworks within our platform. How do we able to bring some more connectivity on our other on-prem platform or other cloud platforms to these ecosystems in a more kind of that future data mesh strategy into the environments? How do we want to institutionalize this a little bit more as we still have a big platform with multiple consumers? The goal is, like Surya said, the replication of the data from the Delta Lake is getting easier. So how do we drive a little bit more of a mesh strategy within our environments to have a function-based or a domain-based mesh into our ecosystems to drive more, I would say, scale within the environment? We absolutely want to streamline and scale our data engineering frameworks as the team learns more and more utilities. It's like once you identify a certain repeatable processes within data engineering, how do we convert that into a utility of a framework so that we can streamline a lot of our data engineering frameworks and continue to evolve data quality checks along the journey? And then enhance our data services with security and flexibility. Today, we have a lot of services which are point-to-point integration, but we need to get through a little bit more of an API-driven architecture with the right security and other data services into the ecosystems to evolve through that. And then the last but not least is GXP in a life sciences pharma is a very big deal. And now as we have this platform working for the enterprise use cases, how do we scale this platform onto the GXP use cases and drive the same features and the capabilities onto the validation and the GXP side of the fence? So that's where we see where we want to evolve through from a Thermo Fisher journey perspective. And with that, I'm going to bring Surya back onto the stage, and we can answer any questions.
Right. Yeah, thank you. Thank you, Ashish. It's great.